Welcome to this final and brief video. We're going to look at wave speed and the wave equation. We're going to contrast it with particle speed. We know that when there is a particle oscillating up and down on a medium, because maybe there's a wave traveling through, and so there are many particles all in this arrangement that looks kind of like the shape of a wave, and the particles each are going up and down. In this type of scenario, the particles are traveling 4 amplitudes every 1 period. So the speed on average of the particle is 4 amplitudes over the period. This is something we've seen, we've used this equation, we understand this. The speed of the wave is not given by this equation. This is absolutely not the same as wave speed. On the test, one of the most common mistakes is that I ask for wave speed, and people use this formula. You can't use this for wave speed. So what's the formula that we can use for wave speed? Well, we know that speed is distance over time. When we're talking about the wave speed, we'll use a very special variable. Our wave speed variable is c for wave speed. And what distance does the wave travel during 1 period? Let's watch that. I'm going to go to slow-mo. So I want to get my ruler up. Here we go. And I'm going to get my timer. And first, I just want to time the period, okay? So when this thing gets to the top right here, I start. It goes down. It goes back up. The period is 0.9 seconds. So now I want to say, how far does it travel in 0.9 seconds? Right? So what I'm going to do is I'm going to get my other ruler. Oh, by the way, let me pause this. What's the wavelength? Let's check the wavelength. Okay. The wavelength is, just under 1 centimeter. So what do we call that? 0.9 perhaps? Okay. So we've got the wavelength, 2, 4, 6, 8, 9. Maybe it's 0.95. We've got the wavelength, we've got the period, 0.9 is the period. Let's watch and see how far a wave travels in 1 period. So you see this wave here? This one? Actually, you know what? Let's do this one. Let's do it like this. Okay, I've got my ruler set up. I'm measuring from the middle of that top bead. And I want to say when this top bead, when this whole wave has traveled for 0.9 seconds, how much farther along is it? So let's go. Okay, I have to let it go for exactly 0.9, so we're at 0.76. So I go a little farther ahead. You see what's happening? Look at that. Here's the original wave. You can scroll back in the video. This was, here's the wave. So where I'm outlining with my mouse. And how far has it gone? It started back here, and now it's right here. So it has moved 0.95 centimeters forward. It has traveled forward exactly 1 wavelength. How long did it take to travel that wavelength? Exactly 1 period. And this makes some sense. Let's write this down. When the amount of time that elapses is 1 period, the distance traveled by the wave is equal to the wavelength, lambda. So wavelength is measured in meters. This is measured in seconds. So you can see lambda over period is going to be meters per second for speed. And what else do we see? Well, wait a second. Hang on now. We could write this as 1 over t times lambda. And what is 1 over the period? It's the frequency, of course. This equation is called the wave speed equation. It's a really important equation for physics. We're going to use this repeatedly, and it's something you've probably seen in chemistry as well. Now, I want to point out that there are 2 equations for wave speed. There's the one down here, which is called, this is called the wave equation. wave equation. And then the second equation we can use is this one. If I tell you that a wave travels 0.3 meters and it takes how long? 0.6 seconds, then you can take that random distance, divide it by how long it took to do the distance, and find the wave speed. However, if I give you frequency and wavelength, that provides a second way to calculate wave speed.